Hi everyone, welcome to lesson 1 of trigonometry. Today we're going to be talking about angles. So the very first thing says draw an angle in standard position. What is standard position? Standard position is always having an initial arm on the positive x-axis. So right here, this is going to be your initial arm, always at positive x-axis, and a terminal arm that can lie anywhere on the grid. So your terminal arm, if you draw an arrow to it, your terminal arm could be, let me just draw a terminal arm on here. Your terminal arm, if you start it off, could be right here on your initial, but it could also be here 90, here 180, down here 270, or back here 360, or basically anywhere in between. So you could basically stop it in this rotation anywhere, and that's going to be considered your terminal arm. The angle is always going to be measured between these terms, between your initial on the x-axis there and your terminal arm. The way that we measure angles, we have two different ways to measure an angle. The first way to measure an angle is in the counterclockwise motion. So basically starting from this x-axis, starting from your initial, and you go counterclockwise, that's going to be our primary positive way to calculate the angle. So from basically our x all the way to our terminal arm there, that's going to be our positive rotation. And from the same x, but going clockwise, that's going to be our negative rotation. Gets you to the same answer, it's just you'll end up with a negative answer. Negative angle, that is. Um, right below, we have two pictures here just to help you out. Standard position, always here on the left. You always have an initial arm on your x-axis, and that's key there. Your terminal arm can be anywhere else on this grid. Not in standard position, neither of your two lines are on the x-axis, and again, what you want is usually one to be on the positive x-axis. Being on the negative x-axis does not mean you're in standard position. You have to be on the positive x-axis to be in standard position. Here we have, in this first example, drawn the angles in standard position. So draw 120 degrees, sorry. Draw 120 degrees. So from our initial, from that positive x-axis, I'm going to draw a line. And this line says, well, if you started here, that's 0 degrees, 45 is around there, 90 is up here, 135 is right there, and about 180 is here. So if I'm looking for 120, 135 is midway right here, so 120 is just going to be a bit higher than that, so I'm going to make this there about 120 degrees. And so again, it's going to be a bit higher than halfway on your graph there to make 120, and let's make it even a bit higher there, just for emphasis. You should label your angles, of course, so I'm going to label it from here to here, from our terminal to our initial, or from the initial to the terminal, that is. This angle here is 120 degrees positive. In the next one, we're trying to figure out where negative 225 is, negative 225 degrees is. Well, for some people, trying to figure out negatives is a bit tougher, so I can figure out the positive version of this exact same answer, or angle. The way that we do that is, if you started from this initial arm here and you went in a full rotation, that's 360 degrees. So I could do a quick subtraction to figure out, well, what is this angle in the positive version of it? So if I did 360 degrees, and that's where, if I went in a full circle, I'd end up there. If I subtracted off 225 degrees, I'd end up with 135 degrees. And maybe this might help you to try to figure out to graph 135 degrees instead of negative 225. Both will net you to the same answer, but it's just the way that some people think rather than others. So, for our terminal arm, we are starting off right here. This is my initial arm at 0. Right there, there's about 90. 135 is going to be in this quadrant here, quadrant 2, and it's going to be halfway between 90 and 180. 135 is right there. The other way we could have done this question is actually truly counted until we get to negative 225. So if you counted from here, our initial, to here, that's negative 90. Again, if you added on another to this flat line, that's another negative 90. So in total, we're at negative 180. So if you're at negative 180, if you went to this next vertical line here, that's negative 270, so we would have overshot it. So we're going negative 180 plus what would get us to this line here at negative 225. That question of what are we adding on is about 45 degrees there. Okay, 45 degrees in this little section there. Overall, this is going to be negative 225 degrees. There you go. Negative 150, negative 150. So again, you could do it the same way that how we did it in example B by trying to find out the positive version of this, or if you're good with negatives, we can start off here. So again, flat line is 0. That's going to be 90 because I'm negative, meaning I'm going in the clockwise direction. So that there is 90. Right here is 180, so I know my answer is down here somewhere, negative 150. So negative 150 is right around here. It's going to be closer to that 180 because it's about 30 degrees difference between the two. So between our x-axis and our terminal, that there is negative 150 degrees. If you had gone the other way, the positive way, that's 210 degrees. Both, again, would have netted you the same answer. So, speaking of same answers, coterminal angles, that's what we were talking about. So two or more angles in standard position are coterminal angles when the terminal arm is in the same position for each angle. So, we're going to test or determine if the following angles are coterminal. The best way to do that, I can just draw them out to compare them. Okay, so if I draw out a few of these here, sorry, I'm just setting up my graphs for all three because I'm going to try my best to draw them all out. There we go. So I have all three set up. So first one is 30 degrees versus negative 330. Well, are they coterminal? 30 degrees, let's draw it in. Let's draw it in a different color so that we know. So again, my initial is going to be on that positive x-axis. 30 degrees looks like it's going to be around here. So if I label that 30 degrees, I should be good for my start. So 30 degrees, again, it's going to be this little angle right in there. So that little angle there is going to be 30 degrees. The question now is, if I went in the positive direction, or sorry, in the clockwise direction, that is, in the clockwise direction, do I get to negative 330? Let's find out. So if I went in the clockwise direction, that's negative 90, negative 180, negative 270, plus another 60. Negative 270 plus another 60 gets me to negative 330. So there you have it. These two lines are considered coterminal, so let's jot that down. Okay, let's draw the next one. So the next one we're looking at 230 degrees. Well, where is 230? So I'm going to do this in two colors. So 230. So again, here's our initial. That's 90. That's 180. Right here's 180, 270. So 230 has to be somewhere in here. So again, 180 is here, 270 is here. We're probably right here. 250, 245, 230. No, yeah, we'll be around here, almost middle, just a bit past the middle there. There we go. And again, I should label this first one here, starting from my initial, going right around to it. This is positive 230 degrees. Let's find 450 and hope that it matches up to this one here as well. So 450, if I start going in circles, so I have my 90, 180, 270, going back here, it's going to be 360. Then let's see if we follow that around. 360 plus another 90, 360 and 90 make 450. So actually my 450 would stop right here. So is this terminal arm here the positive y-axis and this arm here, are they the same? No, they're not. So in this case here, these are not coterminal. This last one, let's check this last one. This last one says we want to graph out something at negative 32 degrees. So negative 32 would be going in the clockwise position. So again, zeros here. 30 is probably around here. So 32 just pretty much similar in angle there. So here's negative 32 degrees. And don't forget to always label your graph. I forgot previously, so I'm going to go back real quickly. In red here, that's 450 degrees. And over here, this is 30. And this is negative 330 degrees. There we go. I've kind of gone back and labeled everything. So in this one here, if I had negative 32 degrees, I want to figure out if I can get to 688 positive. So starting here on our positive x-axis, so here we go. So that's 90, 180, 270, 360, 450. Where am I at? 450. A bit more. That's going to be 6. And if I go 6 plus another little bit here, can I end off here at 688? Well, if I had 688 and if I went to the full rotation, that's about 720 degrees. If I am at 720 minus 32, I'm at 688. So yeah, these two are actually coterminal. There we go. So the next example here is basically asking you for coterminals, but this time without a graph. So I'm asking you to state coterminals and state general form for any angle coterminal to the given angle. So we're going to be starting off with 100. So the fastest way to do this is I'm going to load up my graphing calculator and I'm going to go 100. And to be coterminal to 100, I'm going to add 360 degrees. Well, then the next angle that's going to have the same terminal line with 100 would be 460. So I'm going to write down 460 as a coterminal angle. Another one, because it asked us for 2, another way to do this is if I went 100 and this time I went minus 360. So I'd get negative 260. So negative 260 degrees. Again, these two are going to be coterminal to 100. So 100 is where your initial and terminal arm is. These two are going to be coterminal to this original 100. The question now is, how do we write down an equation that's going to use up and hit all these angles every single time? So the way that we're going to do that is we're going to write down our angle that was given, so 100 degrees. And we're really just adding on an extra 360 because that makes a full rotation. And you don't know how many rotations you want, so I'm going to denote it 360n, where n is an element of an integer. So that means n can only be an integer, so no decimals, no fractions for n. And there you go. That's going to be our equation. Should add on my degree symbols between 100 and the 360. Over here it's negative 75. So again, going straight to my graphing calculator, if I have negative 75, I'm going to add on 360 for the first one to see if I can find the positive version of it. Yep, it's positive 285. Then if I had negative 75, there we go, 75. And if I subtract 360 from it, just like the previous example, we're at negative 435. So let's jot that down. So our two coterminal angles with negative 75 will be positive 285 and negative 435 degrees. Again, these are only examples of what this truly could be, but these are the closest two examples to negative 75. And again, the same thing over here. These are the closest two angles to 100 that are going to be coterminal. To write down our equation, we're going to start off with the angle given. We're given negative 75 degrees, and we're going to go in the 360 degrees direction. But again, I'm going to put n on there, n being an element of an integer, meaning that you can't have decimals, can't have fractions here. Okay, and right here, this is your general note. It says when theta, that's what this symbol is called, theta. Theta represents any angle. Then any angle coterminal with theta is represented by these expressions where n is any integer. So whatever your theta is initial, you're going to add 360n to it, and then n has to be an element of an integer if theta is going to be in degrees. So basically just sub in your value here. So if you had 100, I'm going to sub 100 right in here. Negative 75 is now theta, and then you'd find your coterminals. Principal angle. So principal angle, this idea here means the angle that has to be between 0 and 360 degrees only. And so that's going to be your principal angle. It's always between 0 and 360. I'm going to do a quick highlight of that there just so that that catches your attention, between 0 and 360 only. So if I gave you a few angles, we're going to determine the principal angle of the following. So if I gave you 125, the principal angle is equal to, so let's call it PA for short, is equal to, well, if this is this 125 between 0 and 360? Yes, it is, so it's going to be the same. So 125 is your principal angle here. If you're at negative 15 degrees, I want to find my principal angle, so the way that I'm going to solve this is find the positive version of this. So how do we do that? I'm going to go negative 15 plus 360, and that's going to get me a positive angle, positive coterminal angle that is. That's going to get me 345 degrees. And the question is 345 between 0 and 360? Yes, it is. So that's going to be my principal angle here. Principal angle being 345. Over here, we're well above 360. We're at 753. So how do we solve this one? So I'm going to go 753. And again, I want it between 0 and 360 only. So I'm going to subtract off. So if I subtract off 360, where am I? If I subtract off 360, I'm at 393. Again, we're still higher than 360, so I'm going to subtract off another 360 there. And now where are we at? We're at 33 degrees. And 33 degrees is going to be my principal angle. And there you have it. On this next page here, we're going to talk about reference angles. Okay, reference angles. So what is a reference angle? Reference angle is the acute angle, acute meaning between 0 and 90 only. Acute angle formed on the terminal, by the terminal arm and the x-axis. So you're always looking back towards the x-axis. And again, acute, I'm going to put a quick note right above it. It's going to be between 0, theta, and 90. Your angle has to be between 0 and 90 only. And these are just brackets around there. Okay, so if I'm at 50 degrees, what's my reference angle? Well, my reference, because it's 50 is between 0 and 90, my reference will still be, and by the way, I'm just drawing it in. My reference here, this is in quadrant 1. So the way we denote quadrant 1, just write the letter I there, Roman numeral I, and the reference angle is still going to be 50 degrees, like, because it's between 0 and 90 already, so we're good there. 120, if I drew on 120, 120 is going to be right here. There we go. And so let's jot down a few things here. So you have between here your initial and here your terminal, that's 120 degrees. But I want the reference angle, so the reference angle is always going to be wherever your terminal arm is to the x-axis. So if my terminal arm is here, I want to find this angle right here. From the x-axis to that terminal arm, I want to find that angle. Well, how do I find that angle? Well, my x-axis here was 180 degrees. I want to get back to 120, so I'm going to minus off 120. So that leaves me with 60 degrees. So here, 60 degrees is going to be my reference angle between my x-axis and that terminal arm. Well, here we're in quadrant 2, so that's 2 Roman numerals there, I. And our reference angle is going to be 60 degrees, and we got the 60 right here. There we go. In the next example, 235 degrees. Well, where are you if you're 235? So if you're 235, and let me just sketch that on, you are right down here. A bit more there. So again, let's fill in some of these blank lines. So this here is that's my arrowhead. This is 235 degrees. Here we landed off in quadrant 3. And the reference angle, well, what's my reference angle? Well, again, I want to find from my terminal to my x-axis. My x-axis is right here. So I want to find this small angle right here. Okay, that's what I'm trying to look at. So this line here on my x-axis was 180. To get to this line here, I gotta ask myself 180 plus what would get me to 235. So the question I'm asking is 180 plus what unknown, let's call that unknown there, x equals 235. Well, if I do a quick switch and subtract 180 from both sides, x is equal to 55 in this case here. So my reference angle between my x-axis and my terminal is going to be 55 degrees. So let's fill that in, 55 degrees right there. Last but not least, 300. Well, where is 300 going to be? So again, if I had my initial, that's 90, 180, 270 is right here. So if I add on another 30, I'm at 300. And so 300 is going to be around here. So again, let's start off with which quadrant are we in? Well, this is in quadrant 4. So 4, the way you write is IV for 4 for Roman numerals, IV, that's 4. And I'm going to figure out this reference angle. And so the reference angle I'm looking at is again from the terminal back towards that x-axis there. So it's going to be this small little angle right there. The question is, what's that angle? So if I had 300 degrees to get back to this x-axis, that's another 60 degrees to get to 360. So really it's similar in math here. So if I had 300 degrees, and this time I'm going to add something, and whatever that something is, let's call it theta, is equal to 360 degrees. So theta has to be just 60 degrees. There you go. So my reference angle there, 60 degrees. Last example, last but not least, we got example number 7 here. It says the point A lies on the terminal arm of the rotation angle theta. Draw angle theta in standard position and determine the value of theta to the nearest degree. So let's do a quick sketch is what they're asking us to do. So a quick sketch of this is going to look like the following. If I'm -3, +4, -3, 4 is, well, -3 is going to be 1, 2, 3, somewhere around here, +4 right up here. So let's put a coordinate dot right there. And I want to find this line here from the origin to that coordinate dot. That's what you want to find. So it's easier for me. I'm just going to redraw out a little triangle here and label my triangle. So -3 was on our x-axis because it's always xy, so -3 is going to be right here on our x because we went 3 to the left. 4 is going to be 4 up, so 4 is going to be on our y-axis there. The question is, what is this angle right here? That's the angle we want to find. If we find this angle here, that's going to give us our reference angle, and from the reference you can then find your standard angle. So let's find our reference angle first. Well, what is this? This is from trigonometry. You have your opposite over your adjacent side. I'm going to use tangent. So if I do the inverse of tangent of your opposite over your adjacent, and I'm going to load up my graphing calculator. Again, whenever I see tangent, I'm going to use degree mode. Double check that your mode is in the correct mode. And so here we go. Let's go tan inverse of 4 divided by -3, opposite over adjacent. There you go. You get -53 degrees. So here I can write down this equals -53 degrees, but really, therefore, our reference angle is equal to 53 degrees because reference angle is always between 0 and 90 and it can never be a negative. So our reference angle is going to be 53 degrees. So in standard, I'm asking you to find what is this. Let's change color. What is starting from your initial to your terminal arm? What's this angle here? Well, the way I'm going to do that is I'm going to go 180 because that's where I started, or basically that's a flat line. I'm going to minus off 53 degrees, and that's going to get me my angle. That's going to be 127 degrees, and there you go. That's going to be our answer. So from our initial to this line here, that's 127 degrees. And again, how do I calculate it? If I had 180 on this flat line, if I minus off my reference, I'll get to that standard angle there. In this last example here for for B here, we're at coordinate -7, -2. So what does that look like? Let's first sketch that out. So -7 is going to be on your x-axis, -2 on your y. So -7 means I went to the left, -2 means I went down, and we can do something that looks like this right around there. Again, I'm going to finish this off, draw in a little triangle, and label everything. So my x was -7, so -7 goes on our x. Our y was -2, and again, you want to find that reference angle right in there, because then you can find your standard angle from your initial all the way around to here. And so all you have to do is take 180 plus your reference gets you your standard angle. So let's find our standard angle first. So what is theta? So again, theta is going to be equals to opposite, which is -2 over your adjacent, -7. So I'm going to go tan inverse of your opposite, -2 over your adjacent, -7. And this is going to get me, and again, double check your mode on your calculator. It has to be in degrees mode. So -2 divided by -7, 7. I'm at 15.9 degrees. Basically, I'm going to round that to 16. So right now I have theta equals about 16 degrees, and so therefore, between 0 and 90, my reference angle is equal to 16 degrees. And so to find my standard angle, I'm going to go theta equals 180, because that's that flat line there, plus another 16. So 180 plus another 16 is 196 degrees. And there we go. That's the end of lesson 1.